Hey, welcome back to the IT office. In this video, I'm going to explain you how switches work, okay? If you are preparing for a CCNA exam or CCNP exam or just a real-life network administration and troubleshooting, well, this video is for you. So stay until the end because I'm going to explain you all the details. Let's see this topology we have here. We have two switches, switch 1 connected to Windows 3. We have a switch 2 connected to Windows 1 and Kali 1, and we have this hub connected to Ubuntu 1 and Ubuntu 2, okay? Keep in mind, switches and hubs are different devices. Hubs are basically layer 1 device that sends traffic out of all the ports except for the port it's receiving the traffic, okay? But switches, they have this concept called the MAC address table. Okay, if I run this command show MAC address table dynamic, I will see all the entries, all the MAC addresses, and all the ports those switches have learned the MAC addresses. Okay, in this topology I did something to simplify. Remember, I told you MAC addresses are assigned physically to the devices and those are fixed, right? But there is a way to spoof the MAC address on the devices, so I did that for Windows 1, Windows 3 and Kali 1. So if you see this MAC address starting A, and then once this is Windows 1, and this below ending in 2s is Windows 2, and this ending in 3s is the Kali Linux device. Okay, so from the perspective of switch 1, it is learning the MAC address of Windows 1 through gigabit 00, which is the port connecting to switch 2. That makes sense, right? Because all the frames that comes from Windows 1, for example, goes to Windows 3, have to pass through gigabit 00, right? So it will learn that that traffic from that source will come from gigabit 00. Now, if we see, for example, this entry below, this corresponds to the MAC address of Windows 3, which is ending in 2 and is being learned through port gigabit 02, because when Windows Server 2 sends a packet, a frame, the switch will record that entry in the port it receives the packet, which is gigabit 02. And this one below also it's been learned through gigabit 00. This corresponds to the MAC address of the Kali Linux device. If I want to double check the MAC address, I can run the command ipconfig. Also, this is Windows 1. You see the spoof MAC address ending in 1. Now in Windows 3, ipconfig all, and this is Windows 3, the MAC address ending in 2s, and ipadd here, this is the MAC address ending in 3s. Very simple, right? In this case, the switch have learned all the entries for all those devices in the network, right? Each device can communicate. For example, we can ping here Windows 3 and we can ping Kali Linux device, and everything seems to be fine, everything is okay. But let me show you the following command: clear MAC address table dynamic. In this case, if I double check the MAC address table, well, it will start learning the MAC address of the devices when those devices sends traffic, right? So for example, here I see the MAC address of Windows 1, and if I start pinging Windows 3, now we will see that entry also, because the traffic will come from Windows 1, go to switch 2, go to switch 1, then to Windows 3, and then the response is coming into gigabit 02, back to switch 1, then go to switch 2, and so on and so forth. Okay, So this process of handling the frames, checking the MAC address table, and then sending the traffic is called forwarding. That's the regular process when the switch already knows all the entries for all the devices and is, let's say, in a stable state, right? Like it already learned the MAC address entries and it knows where every device in the network is located. Okay, so there is another process called flooding. Okay, let me show you that process. That's going to be tricky to demonstrate, but let me do the following. So you see here now we are in the terminal of switch 2. I'm going to start sending packets from Windows 1 to Kali Linux 1, right? So in this moment, all the devices have, for example, the ARP entries of the other device, and they already learned through the ARP process the IP MAC association, right? So let's leave it like that. I'm not going to clear the ARP because we already studied that process and I need that to be working for the following test. Okay, if you see, if I send traffic from Windows 1 to Kali 1, the switch is going to receive the frame in gigabit 02, right? And the destination in that frame, when I ping it from Windows 1 to Kali 1, the destination is going to be this MAC address, right? Which is the Kali 1 MAC address. So the switch will send a packet out gigabit 03 only. That's forwarding, right? Because it's a unicast packet and the switch knows where the destination is. Same for the return traffic. So Kali Linux is going to send the traffic back and the switch will check the destination that now is Windows 1 MAC address. So it will send it to gigabit 02. So for this demonstration, I'm going to capture packets in the connection between switch 1 and switch 2. Now I'm going to explain you why. Let me start the capture, right? Let me move this window to this other screen. Let's go back to the devices. So now let me filter by ICMP. Okay, that's okay. So if I ping from Windows 1, if I ping Kali Linux, since the switch, look at the switch, right? That traffic is going across switch 2 to Kali 1 and the response is going from Kali 1 to switch 2 and then to Windows 1. That's it, right? Basically forwarding, right? Now to demonstrate the following process, which is called flooding, okay, I'm going to keep this capture running, but now I'm going to clear switch to MAC address table so it doesn't have any MAC entries. I'm going to ping again, right? And let's check the MAC address table again. Let me see. Now I see traffic, right? I see some traffic, so I see MP packets that came from Windows 1. You see, this is Windows 1 IP is 10.10.15.11. The destination is 10.10.15.200, and then I see a response. You will be wondering why. So let me show you why. Because the MAC address table was empty. Okay, the switch, if it receives a unicast packet, in this case was a packet from Windows 1 to Kali 1, was a unicast packet. Since the switch doesn't know where the destination device is because it doesn't have the MAC address entry, it will flood the packet. That packet, initial packet from Windows 1 to Kali 1, when we didn't have that entry in the MAC address table, the switch will send a copy to switch 1. That's why we see here in this capture that was taken in, let's say, in the cable between switch 1 and switch 2, we see that ICMP packets, right? And then we have some ICMP packets going out, also a copy to Kali 1, so it will receive the packet, and then we have some packets sent to the hub, right? So that's a basic demonstration about how the flooding process works. So remember, if we're sending unicast packets, right, like in this case from Windows 1 to Kali 1, and the switch doesn't know where the destination MAC address is because it doesn't have the entry in the ARP table, it will do this process. It will flood the traffic, and then it will start learning again the MAC address entry. As you can see here, you already have the MAC address entry now. Okay, so that's a very interesting process. Also, the switch has to flood traffic like broadcast, for example, in the ARP resolution. So that's a very interesting process. That's why we call this flood and learn, because we flood traffic, then we learn the entries. Okay, if you see, for example, systems like SDN or software defined networking, they do learning in the control plane. This is called learning in the data plane, right? Because we have to send data in order to learn and build the MAC address table. Now let's go to the last process I'm going to show you. So we have two devices here below connected to a hub. The hub is a dumb device. It's basically a cable. It's a layer 1 device. It doesn't do any learning. It just sends the packets it receives through all the ports. Okay, so for example, if Ubuntu 1 sends a packet to Windows 3, the hub will send it out E1, E0 port and E2 port, right? If Ubuntu 2 is sending traffic to Ubuntu 1, it will send a packet out E1 port to Ubuntu 1 and out E0 port to switch 2. So it's a dumb device. But now the switch has another function which is called filtering. Let me show you. This will be fun to test. So what I'm going to do is I'm going to do a ping from Ubuntu 1 to Ubuntu 2, and I'm going to capture packets here, right, between gigabit 01 of switch 2 and E0 port of the hub. But first, let's stop this other capture so we don't have those many captures running. Let me stop this one. Let me start this capture. Let's start it. And let me go here, open the terminals. Let me also quit this. Let me start Wireshark. Okay, so let's see the terminal devices. I'm going to do the same ICMP. Now also, you know what, I'm going to capture here because I want to show you how the process works, but I need you to see this detail here, right? So first we're going to capture again ICMP and ICMP here, right? ICMP, the filter. Now let's go here. This device has the IP address 10.10.15.21 and Ubuntu 2 is ifconfig 10.10.15.22. Okay, you can see also the MAC address of these devices here. This ends in 41FF and this one 47FF. So I'm going to ping 10.10.15.22. Okay, see this capture here, and let me stop it right there. So this one, you see that this device send the traffic, right? This hub device send the traffic to switch 2. Switch 2 received the first frame and it forwards it because probably it didn't have that entry in the MAC address table and did forwarding. But after learning that MAC address, it won't forward that traffic anymore because it will learn those MAC address from here. Let me double check the MAC address entries. Let's see. 40B-A2 is Ubuntu 1. So if we see 44B-A2, I don't know, I keep saying 40, I don't know why. And then 87.8.8B. Okay, and those two entries are learned through gigabit 01. What happens is the following. When the device starts sending the ping packets, it will send it to the hub. The hub will put a frame on E0 port that switch 2 will receive, and also will put a frame in E2 port that Ubuntu 2 is receiving, right? Then we have the response, and it will do the same. It will send this frame out switch 02 or switch 2 and Ubuntu 1. So the hub, which is a dumb device, will send a copy of the frame to the switch. But the switch, if you see here, first frame it will flood because probably it didn't have the entry. But after it learns that these two MAC addresses are connected back to port gigabit 01, it filters the rest of the packets, right? So it won't send any other packet upstream because remember, switch are very smart and they rely on the MAC address table. In this case, they did filtering. So 3 processes. Forwarding, they know the entries, they know where the devices are, they just forward the traffic, okay, based on the entries they have in the MAC address table. The other process is flooding. When they receive a unicast packet but they don't know where the destination is, it will flood the frame out all its ports except the one it receives the traffic. And then the filtering process, when he receives a frame through a port and the destination of that frame is out of the same port, it will drop the packet, okay? So basic rules for the switches, that how switches work. So I hope you have enjoyed this video. Remember, subscribe, like the video, share, and see you in the next.